All right, so we're off to a couple of quicker problems here. Looking at the vertex, let's see what happens. So again, big fan of completing the square myself. So when I'm ever asked to get a problem into vertex form, we did another problem. This is a little repetitious. Let's take this 8, cut it in half and square. Let's make it balanced by subtracting 16, since these would kind of cancel out. You know, you do this all the time. You know, you go up to somebody and hand them $5, and then they give you $5 change out of their cash register. So if you add $16 to the cash register and took $16 away, everything's going to be perfectly in balance. And this is perfectly x plus 4 squared minus 19. So this is your vertex form, but if we wanted the actual vertex, it would be here. Now, factoring, of course, is nice and quick. If the leading coefficient is 1, which it is in this case, we are just looking for two numbers whose product is 56 that have a sum of negative 15. And so you can tell that 7 times 8 would be 56, but if they're both negative, they would have a sum right here. Now, 29 got a little teeny bit harder because one of the rules is if there's a number that they all have in common, your GCF is always your first step. Now, I didn't do that up here because I only had a 1 in front. So there was no value that I could actually consider for greatest common factor. This one has one. So I'm going to start by factoring a negative 2. And factoring is a fancy word for divide. So I divided this one by negative 2, I divide this one by negative 2, and this one by negative 2. And now, if I ignore this front piece, it's like this previous problem. I just have to think of two numbers whose product is negative 15 and whose sum is negative 2. And there we go. Now, number 30 is by a mile the hardest problem. But it's really not that bad, but it is definitely longer. I'm looking for GCFs, and I'm noticing that all three of these values are, in fact, even. And you might look for something bigger, but, you know, 2 and 5, but only, well, 2 goes in, but 5 doesn't. So I guess 2 is it. So we're going to start with this. And unfortunately, that puts us into a little bit of a pickle because we don't have that leading coefficient as 1. So let's talk about how we played this game. I'm going to kind of do some work up here so I have some room. When we had these problems, one of the things that we would do is we would take A times C, and we would put B here in the middle. And I think you could probably recognize that 15 times 2 is 30, but if they were both negative, we would get the appropriate sum. So the way we did that back months ago now, we had put the 6x squared and the 5 here, but instead of putting negative 17x, we put negative 17x by putting them both there. Now, one of the ways that you know you're right is that if you look at the diagonals, see the 30x squared and the 30x squared, if those diagonals match, you did well. That's really important. And then all we have to do is look for greatest common factors. And I notice that these two right here both have a 2 in common. They also have an x in common. And 2x times 3x, 2x times negative 1, 3x times negative 15. This all is nice and pretty. And there is my fully factored problem. Now, one of the things that I used to do when I was younger, when I factored, actually, I guess this really wasn't so much when I was younger. I didn't have quite this fancy of a calculator, but some things I will do maybe when I'm like figuring out whether or not I did something right. Maybe I'm making an answer key for a test or making a video review and wanting to make sure that no mistakes were made. These two answers should be the same. So I just typed the original problem in and my factored form. Now, if I graph this thing, I should see one single graph that should be one on top of the other. That's a little confusing because it's hard to know if they literally are on top of each other or if maybe one of them isn't on the screen. But one thing that I will do is I'll hit second graph, which is table. And if you look over here at the table, you can, depending on how you have your calculator set up, you can ask a few different questions. And so notice that no matter what value of x I pick, these match, which tells me it looks like those two graphs were in fact identical. All right, moving just a little bit deeper into this thing right here. Let's see if maybe we can do one more of these, and then we'll use the next video to carry from there. I'm trying to keep them about 5 or 6 problems each. Now, this is a system of linear equations, and it's called that because those are both lines, and we could make a big graph and try to graph it or do something fancy, but the smart play in this case is to use substitution. So this x right here, I could replace with 5y and 32. So 2x minus y is negative 13. And instead of putting an x right here, I'm going to put negative 5y plus 32. Quick distributive property. Let's combine our like terms. And last, let's move this 64 to the other side. Now, of course, if we took negative 13 and we subtracted 64, we should get negative 77. I just wanted to make sure I didn't make a mistake there. And so I got the y itself was 7. But in a system of equations, I see people do this all the time, is they think, oh, I finished, I solved it. No, you need x and y. So if I know what y is and I plug it right there, x is supposed to be negative 5 times y plus 32. See, negative 5y plus 32. But instead of putting a y there, let's put a 7, which is negative 35 plus 32. And that would be negative 3. And that should do it for the video up through problem 31. All right. Have a good one. See you soon. Bye.